So stratigraphy, as we all know, is the study of layers. Okay, the study of layers. Basically, it is study of entire geology. Okay, so stratigraphy basically is the extract of geology. Okay, it is extract of complete geology. It should be, it should include everything, anything and everything whichever you have studied in geology, right? You have studied mineralogy, you have studied the geomorphology, you have studied paleontology, you have studied economic geology, right? Ore forming processes. After that, you have studied petrology, the most important thing, right? Petrology, igneous, metamorphic, sedimentary, all the petrologies. Okay, all these things when they are clubbed together for a particular area. Okay, for a particular area. Say suppose for Maharashtra, or in Maharashtra, we have one specific area called Nagpur. Okay, one specific area called Nagpur, and whichever geological processes might have been dominant, or which processes are have given rise to the present scenario or present geological nature of this Nagpur area. Okay, that will cover into the stratigraphy. Okay, that will occur, that will be studied under the stratigraphy. So in the vicinity of Maharashtra, we have to study the formations right from Archean to recent. Okay, so we'll begin with the stratigraphy. Right. So the stratigraphy of Maharashtra. Now, this stratigraphy of Maharashtra, I'll just briefly give you the overview. Okay, I'll briefly give you the overview, and then we'll start the detailed discussions over all these things. Okay. So the stratigraphy of Maharashtra is somewhat special. Okay, it's somewhat special, and it is threefold. Okay, it is a threefold stratigraphy or threefold division. Not basically the division, but threefold stratigraphy, because there are three time divisions or three divisions which can be done according to this Deccan traps. Okay, Deccan traps. So there is something which is called as pre-trap formation, pre-Deccan trap, previous to that of the Deccan trap. Okay, when there were no Deccan traps, there was deposition going on. Okay, at that time deposition was also going on. Igneous processes were also going on. Metamorphic processes were also going on. So whatever the processes, whichever the processes those were dominant. Okay, whichever the processes those were dominant during pre-trap, that means previous to or prior to that of the Deccan trap, prior to that of the emplacement of Deccan traps, those formations are the pre-trap formations. Okay, those formations are the pre-trap formations. Then comes the Deccan traps. Okay, Deccan traps. We have dealt with the Deccan traps in detail in the previous class. Okay, so Deccan trap comes, Deccan trap, and then it covers almost 80% of state. Okay, it covers almost 80% of the state of Maharashtra. And then comes the post-trap formations. Okay, the post-trap formation, that means the formations or the geological feature or the geological record after the Deccan trap. Okay, after the Deccan trap, right? So it is post-trap formations. Okay, so it is pre-trap formation, Deccan trap, which is the midpoint, which can be considered as midpoint, and then post-trap formations. Okay, post-trap formation. So this is the threefold division, or this is a threefold stratigraphy of Maharashtra. So let us see them one by one. The first one is the pre-trap formations. Okay, pre-trap formation, that means what rock formations or which kind of rocks were dominant in the earth or in Maharashtra, in the state of Maharashtra, before there were the Deccan trap, or before the emplacement of Deccan trap or the Deccan basalts. Okay, so starting with the very beginning of the Earth's record, Earth's rock records, that is Archean. Okay, Archean. So Archeans, we have the Archeans with older schists and unclassified crystallines. Okay, so older schist belts are present, the schistose rocks are present, and the crystallines are there. The crystalline rocks are there, which are unclassified. They are not classified to any any kind of group. Okay, they have not given the status of any kind of group or supergroup or formation or bed, anything like that. Okay, they are just rocks which belong to Archean age. Okay, Dharwadian rock. Okay, Dharwadian rock, that means the rocks which are equivalent to that of the Dharwad. Okay, the rocks which are equivalent to that of Dharwad. Okay, where is Dharwad? धारवाड़ कहाँ है? कुठे है धारवाड़? Dharwad is in Karnataka. Okay, Dharwad is in Karnataka, and geologically it is the largest craton. Okay, Dharwad is the largest craton. Okay, geologically it is the largest craton and actually well studied craton. Okay, well studied craton, and it is very much near to the. Okay, it is just like lying to the our state of Maharashtra. Okay, so these Dharwadian rocks, okay, these Dharwadian rocks in Maharashtra, okay, Dharwadian rock in Maharashtra, they are nothing but saucer, which belong to lower Dharwads, okay, which belong to the lower Dharwad, and Sakoli and iron ore group, okay, Sakoli and iron ore group, which belong to middle Dharwad age, okay, they belong to the middle Dharwad age. So remember this equivalents of Dharwad, okay, equivalents of Dharwad in Maharashtra are Sausar, Sakoli. Okay, they are Sausar and Sakoli, which constitute basically the Bhandara triangle. Okay, you might have heard this word, the Bhandara triangle. We'll be taking this Bhandara triangle. Okay, so they are called as the Dharwad. They are the equivalents of Dharwad, of the Dharwad rocks in Maharashtra. Okay, and these rocks or these granite, these Archean rocks in Maharashtra, they are intruded by granites and diorites. Okay, they are intruded by the granites and diorites. So there are many episodes of intrusions. Okay, many episodes of intrusions in these Archean rocks. Okay, and they are intruded much by the granites and diorites. Right. Next is Kadappas and Vindhyans. Okay, the Kadappas and Vindhyan. So these sediments of Kadappas and Vindhyans, they occur in Sindhudurg and Kolhapur districts. Okay, this Kadappa and Vindhyan, the sediments of Kadappa and Vindhyan in Maharashtra. Okay, in Maharashtra, they occur in the Sindhudurg and Kolhapur districts. Okay, so they have not undergone metamorphism much or large. Okay, there is metamorphism, but there is little or no metamorphism at all. Okay, then comes this Paleozoics. Okay, so in peninsular India itself, okay, in peninsular India we do not have these Paleozoic formations. Okay, in peninsular India we do not have the this Paleozoic formations. Okay, then comes Gondwana. Okay, then comes the Gondwana. Now in Maharashtra we have Gondwanas. Okay, we have Gondwanas with coal beds. Okay, we have Gondwanas with coal beds. Where do in Maharashtra we do have coal? Chandrapur, Kamti, Wardha, Umred, correct. Umred, Wardha Valley. Nagpur, Kamti.
Yes, sir.
Kamti is in Nagpur district itself. Kamti, Kanhan, Gosillewada, everything. Okay. So in the eastern parts of the state, okay, in the eastern parts of the state, we have these Gondwanas. Okay, we have the Gondwanas which have coal beds. Okay, which have these coal beds, and larger types of coal deposits are present in Chandrapur district. Okay, larger coal deposits are present in Chandrapur district. The smaller kind of deposits, for smaller types of coal deposits are present in Nagpur district, in and around Nagpur district itself. Okay. Next comes, so this is one class. This is one time frame. Okay. Chandrapur Black Gold. Okay. Next is the Deccan tribes. Okay. Next is the Deccan tribes. Now, these Deccan tribes, they have changed the entire course of geology in Maharashtra. Okay, the entire course of geology in Maharashtra. So, which was coming to like Gondwanas. So, Gondwanas are essentially the sedimentaries. Okay, these are sedimentary rocks. Okay, these are the sedimentary rocks starting from tillites. Okay, starting from tillites, you might have studied the Gondwanas in detail. Okay, Gondwana starts from tillite, the Talchir. Okay, then larger then this it proceeds forward. Okay, it proceeds forward and it has conglomerates, then it has sandstone, then it has shell, ironstone, all these things. Okay, so essentially Gondwanas are the sedimentary rocks. Okay, they are the sedimentary rocks, and this is evidence of its being sedimentary. Okay, because coal occur in the Gondwanas. Okay, next it comes the Deccan traps. So above sedimentary we have Deccan traps. Okay, above sedimentary rocks, above the sandstones and these kind of rocks, we have the Deccan traps. Okay, so in Deccan traps, I have told you about two concepts. Okay, I have told you about two concepts: intertrap and infratrap. Right, infratrap and intertrap. These two concepts I have told you in case of these Deccan traps. Right. So infratraps are found in the Dhule district. Okay, the infratraps are found in Dhule district, which is close to Narmada Valley, and these are called as Bagh beds. Okay, these are called as the Bagh beds. So these Bagh beds, they occur near the Dhule district. Okay, and this Dhule district is very much nearer to the Narmada Valley. Okay, so in Narmada Valley, these infratraps, okay, these infratraps occur as a series of inliers amidst the Deccan trap formation. So in the Deccan trap formation itself, okay, in the Deccan trap formation, they are like inliers. Okay, they are like the inliers. What is inlier? I hope you know this concept, inlier and outlier. What is inlier? Inlier, outlier?
Sir, younger surrounding the olders.
Younger surrounded by olders. Or outlier?
Sir, just reverse. Older surrounded by younger. Older formation surrounded by younger.
Older formations surrounded by younger formations. Okay? These are inliers and outliers. Okay? So lamatas also occur, or lamata also happens to be the infratrapians. Okay, the lamatas are also happen to be infratrapians. Okay, so these are infratraps which are present in the, okay, these are the infratraps which are present in Maharashtra.
सर ये इंफ्रा टैप्स का एक बार बताइए ना, वो डेक्कन ट्रैप में कहाँ मिलता है इंफ्रा और इंट्रा ट्रैपियंस?
क्या
डेक्कन में इंफ्रा और इंटर ट्रैपियंस ये कैसे पहचाने जाते हैं? वो समझ में नहीं आया, भूल गया था मैं.
इंटर एंड इंफ्राट्रैप्स.
यस
तो
सर.
इंटर ट्रैप्स क्या होता है, एक मिनट अगली स्लाइड पे आने दो, वो हो जाएगा क्लियर.
ठीक
ठीक है. Okay. So in the Deccan traps, what Deccan traps actually is, it's a basaltic lava flows. Okay, they are the basaltic lava flows. Tons of basaltic lava flows have occurred. Okay, the large amount of lava flow has occurred, and this lava flow has given rise to the entire Deccan trap or entire Deccan plateau. So these flat plateau, flat top plateaus, they are composed of several flows. So like this. Right, there are a large number of flat topped plateaus. Okay, large number of flows, and it has given rise to the flat topped plateau. Right, so this is this is Deccan trap. Next is intertraps. Okay, next is the intertraps. Now what is this intertrap? Intertrap is the intercalation of sedimentary beds. Okay, this is the intercalation of the sedimentary bed. And this intercalation of sedimentary beds, they are fertile and lacustrine deposit of restricted extent. Okay, now Sonal has asked what is intertrap and what are infratraps, right? What is intertrap and what is infratrap? See, there is one flow. Okay, there is one flow, this is another flow. ठीक है, ये दो फ्लोज हो गए. ठीक, now in these two flows, this is igneous, this is igneous. अब इन दोनों के बीच में आएगा आपका सेडिमेंट्री. ठीक है, दो इग्नियस के बीच में एक सेडिमेंट्री आ गया. इट इज जस्ट लाइक अ सैंडविच, राइट? इट इज जस्ट लाइक अ सैंडविच दैट नीचे एक बसाल्ट की लेयर है, ऊपर एक बसाल्ट की लेयर, और बीच में ये क्ले की लेयर कहां से आ गई? ठीक है, बीच में ये क्ले की लेयर कहां से आ गया, फिर सेडिमेंट की लेयर कहां से आ गई? ठीक है, either it may be sediment, either it may be clay, it may be anything, right? So this is due to the deposition during the rest time of the volcano. Okay, during the rest time of the volcano means when there was no volcanism. Okay, when there was no volcanism, no lava flow was coming. Okay, no lava flow was coming at that time. This area, ये जो पूरा एरिया था, वो पूरा एरिया अंडर वाटर चला गया. ठीक है, वहां पे लेक्स बन गए बिकॉज देयर वाज सम डिप्रेशन. ओके, वहां पे लेक बन गए या फिर वहां से कोई स्ट्रीम फ्लो हो रहा होगा. ठीक है, ये लावा ऐसा थोड़ा सा ऊपर उठ गया. ठीक है, बहुत ज्यादा स्टैकिंग की वजह से. तो इधर क्या हुआ, पीछे का वाटर पूरा का पूरा रुक गया, विच इज कॉल्ड डैमिंग. ओके, विच इज कॉल्ड डैमिंग. इस डैमिंग की वजह से पानी पीछे का पीछे रह गया. ठीक है, नाउ द फ्लोइंग वाटर कंडीशंस हैव नाउ कन्वर्टेड टू लैकोस्टाइन कंडीशंस. ओके, fluvial conditions are now converted to lacustrine conditions, and here there is a formation of a lake, a temporary lake basically. ठीक है, ये permanent lakes नहीं होते, these are the temporary lakes, and these temporary lakes have accumulated large amount of sediments. ठीक है, they have accumulated large amount of sediments, and when the second layer, ये ऊपर वाली जब लेयर आई, ठीक है, ये ऊपर वाली जब लेयर इसके ऊपर आ रही है, तो वो क्या करेगी, इस पानी को सबसे पहले हटा देगी. ठीक है, पानी को सबसे पहले हटा देगी, और पानी को हटाते हटाते इसका टेम्परेचर कम हो जाएगा. ठीक है, टेम्परेचर विल बी लोअर्ड, एंड दिस लोअर्ड टेम्परेचर will carry out a baking effect here. Okay, it will carry out the baking effect, and this baking effect will create the intertraps. Okay, they will create the intertraps which are evident from bowl beds. Okay, bowl beds, I have told you two types of bowl beds. कौन से दो टाइप के बोल बेड्स बताए थे मैंने?
रेड बोल, ग्रीन बोल.
रेड बॉल,
रेड
ग्रीन
बोल,
बॉल.
और दूसरा ग्रीन बोल. Why red bowl is called red bowl? Because it has
iron.
iron oxide, right? It has iron oxide. Green bowl is called green bowl because it has
Elite.
Right? It has elite. It has essentially green colored mineral. It has essentially red colored mineral. ठीक है, it has red colored mineral. It has green colored mineral, and hence these coloration or these colors are imparted to this. Okay, these colors are imparted to these bowls, and wherever there are bowls, wherever there are bowl beds, that indicate the presence of sedimentary conditions. Okay, that indicate the presence of sedimentary conditions, and hence by knowing these sedimentary conditions we can interpret the presence of intertraps, right? The presence of intertraps. दो ट्रैप के बीच में हुआ तो इंटरट्रैप. अगर दो ट्रैप्स दो सेडिमेंट के बीच में ट्रैप आ रहा है, then it will be infratrap. Okay, समझे सोनल?
यस सर, वो इंफ्रा ट्रैप में भी सेम कंडीशन रहेंगी ना?
कंडीशन सेम ही है,
बस
कंडीशन सेम है. वो इंफ्रा ट्रैप इंटर ट्रैप एक ही बात है.
रेड बॉल ग्रीन बॉल वाली, बस
ठीक
वो
है,
दो सेडिमेंट के बीच में एक आ जाएंगे.
जस्ट उसकी लोकेशन का फर्क पड़ता है. ठीक है, सिर्फ उसकी लोकेशन का फर्क है, बाकी कुछ खास फर्क नहीं, दोनों में एक ही है. ठीक है, कई जगहों पे इंटर ट्रैप और इंफ्रा ट्रैप एक दूसरे में कन्वर्ट होते हुए दिखते भी है. ठीक है, सो इंट्रा ट्रैप इंटर ट्रैप गेट्स कन्वर्टेड टू इंफ्रा ट्रैप बिकॉज कहीं ऊपर जाके उसका ये फ्लो खत्म हो गया होगा जस्ट लाइक दिस। ठीक है, ये एक है और ये फ्लो यही तक था। ठीक है, ये फ्लो यही तक है। तो अब क्या हुआ, ये जो अंदर का सेडिमेंट है ठीक है, अब ये इसको क्या बोलोगे, इसे क्या बोलेंगे,
इंफ्रा
इंटर।
इंटर
ये
इंटरट्रैपियन।
ये जो मैंने जितना
इंटरट्रैपियन।
ग्रीन ग्रीन कलर में दिखाया, ठीक है, ये वाला पोर्शन, बिकॉज ये देखो एक रेड दूसरा रेड और दूसरे के बीच में व्हाइट की लेयर आ गई। ठीक है, दिस इज नथिंग बट योर इंटर ट्रैप। ओके, अब इधर देखो, सेम ट्रैप आगे जाके कंटिन्यू हो रहा है और इसके बीच में एक रेड की लेयर आ गई है, ये वाली। So that same bed, same intertrap bed is now getting converted to infratrap, right? This is nothing but one and the same thing.
ओके सर।
Okay, so this is intertraps and infratraps and is Deccan basaltic plateau or Deccan basaltic province, right? Next, post trap formations. Okay, post trap formation after what after basalts. Okay, what after Deccan traps. So after Deccan traps, what do we have is alluvium. Okay, is alluvium. Okay, so Tapi and Purna alluvium is there. Okay, Tapi and Purna alluvium. Tapi and Purna are the two prominent rivers in Maharashtra. Okay, so all along the foothills of Tapi and Purna Valley region, the coarser clastics, including sand, gravel, and conglomerate, that exceed the finer clastics and argillaceous materials derived from stream sediment. So they carry all the materials from their respective watersheds. Okay, from the respective watersheds, they carry entire material and they deposit that material at the foothills of the Tapi and Purna Valley region. Okay, at the foothills of Tapi and Purna Valley region. So these are highly unconsolidated. There is no binding. Okay, no binding, and regular at the regular interval, these kind of aluminum is coming over there. Okay, it is coming over there, and due to this, okay, due to this, this is unconsolidated. Okay, this is unconsolidated. Okay, so there is no consolidation. Okay, there is no lithification of the sediments for this kind of materials. Okay. Now the last thing, okay, the last thing which occurs in Maharashtra is laterites. Okay, laterites. Now what is laterite? Laterites are the thin cappings on the top of Deccan plateau. Okay, these are the thin cappings which are present on the top of the Deccan plateau. Okay, लाल कलर की जो सॉइल होती है, ठीक है, मुरुम ज्याला म्हणतो आपण, मुरुम, that is laterite. Okay, it occurs in Jat taluka of Sangli district and Ausa, Nilanga and Udgir talukas of Latur district. Okay, now they are classified into two types. Okay, they are classified into two types: coastal laterites and interior laterites. Okay, coastal laterites and interior laterites, where coastal laterites are basically younger than that of the interior laterites. Okay, the coastal laterites are younger than that of the interior laterites. Okay, remember this thing. Remember this thing. Coastal laterites are younger than interior laterites. Okay, clear till this? Clear till this point?
Sir, but what is coastal and interior laterites?
What is?
What is coastal and interior laterites?
Coastal laterites are those which are formed along the coastline of Maharashtra. Okay, and interior are those which is formed in internal part of the state, which is far away from the coasts.
Okay, sir.
Okay, so that is interior and that is interior and coastal laterites. Okay.
सर कोस्टल लैटेराइट्स रहा तो वेस्टर्न घाट को डिमार्केट कर सकते हैं क्या?
हाँ, वेस्टर्न
घाट
घाट्स,
बोल सकते हैं।
वेस्टर्न घाट्स में अरेबियन सी का जो कोस्ट लाइन है पूरा, ठीक है, अरेबियन सी का पूरा कोस्ट लाइन that will be covered by this coastal laterites. See? So this is the overall geological map of Maharashtra. Okay. Once I will share this, go through the map. Okay, go through the map. See, majority of the area is covered with green color. Okay, majority of the area of the state is covered in green color. This green color indicates Deccan basalt. This green color, this green cover indicates the Deccan basalt. Okay, this indicates the Deccan basalt, and this portion of Maharashtra state. Okay, this portion of Maharashtra state, basically Vidarbha region. Okay, the Vidarbha region, eastern state, eastern parts of the state, and the smaller portions of this here. Okay, the southern part of the state. Okay, the southern part of the state and the eastern part of the state, which are nearer, okay, which are relatively nearer to the Dharwad Craton. Okay, relatively nearer to the Dharwad Craton. These will show different formations. Okay, these will show different formations. Or else, if these were not the part of the geographic territory of Maharashtra, there would have been only Deccan basalt in Maharashtra. Okay, there would have been only Deccan basalt. So the stratigraphy of Maharashtra would be very, very simple. Okay, the stratigraphy of Maharashtra would have been very, very simple. Okay, what you have to study? Just study the Deccan basalt. That's it. Okay, just study the Deccan basalt and the stratigraphy of Maharashtra is done. But just because we have these areas, okay, these areas with in the geographic territory of Maharashtra, we have to study the geology of these areas as well. Okay, so kindly go through the map. Once I'll share the notes. Okay.
सर पण ते पूर्णामध्ये अचानकच ते अलुवियम कसं काय आलं सर? तिथे डेक्कन बसाल्ट नाही आला.
कुठे?
हा पूर्णाचा जो रिजन आहे, पूर्णा रिव्हरचा.
पूर्णा रिव्हर वाला रिजन. That is due to
erosion.
Erosion मुळे आले होते.
अच्छा, ठीक आहे.
आता आधी डेक्कन बसाल्ट आहे. डेक्कन बसाल्टला कापून त्या नद्यांनी आणलाय ना, पूर्णा आणि तापी यांनी पूर्ण डेक्कन बसाल्ट कापून आणलाय. आता तो जो कापून आणलेला डेक्कन बसाल्ट आहे त्याचं सेडिमेंट्स कुठे टाकतात? कुठे ना कुठे डिपॉझिट करतील. That deposition is nothing but alluvium.
Okay, sir.
ठीक है. So moving towards the detailing of all these things whichever we have studied. Starting with this peninsular gneiss. Starting with the peninsular gneiss. Basically, peninsular gneiss is the basement for everything. Okay, peninsular gneiss is the basement for everything in specifically in southern India. Okay, specifically in southern India or in you can say the peninsular India. Okay, the peninsular India. So in peninsular India, this peninsular gneisses, okay, these peninsular gneisses are collection of heterogeneous acidic rocks. Okay, these are heterogeneous acidic rocks. Just the collection of heterogeneous acidic rocks. These are not just the gneisses; they are gneisses and granites. Okay, gneisses and granites. So they have migmatites, they have gneisses, and they have granitoids as well. Okay, they have granitoids as well. Granitoid means entire granite clan. Okay, entire granite clan. So then chemical classification of granites may be covered, then physical classification will be covered, right? IUGS classification will be covered. Every rock, okay, all the rocks will be covered under this one heading, that is granitoid. So entire granite clan. Okay, so the entire granite clan can be seen here in the peninsular gneisses. Okay, but these were not evolved or these were not emplaced is instantaneously. It was evolved during a long span of time. Okay, it was evolved during a long span of time, and this span of time ranged from 3.3 to 2.6 GA or billion years. Okay, 3.3 to 2.6 billion years. Okay, so peninsular gneiss took these large amount of time, this large amount of time to be to come into existence. Okay, so the composition of these gneisses, okay, the composition of these gneisses have undergone a change from transhemitic, tonalitic to granodioritic and granitic. Okay, so there is originally transhemite, tonalite, okay, tonalite, transhemite, and then it is converted to granodiorite, then granite through reactivation, melting, and potash metasomatism. Okay, so these are different processes. Okay, these are the different processes which occurred. Okay, these are the different processes which occurred during the emplacement of these peninsular gneisses. Okay, during the peninsular gneisses, and these peninsular gneisses have been changed, or the composition of these peninsular gneisses have been changed from transhemite, tonalite to granodiorite and granites. Okay, so the major phase of the peninsular gneisses, they exhibit intrusive relationship with the Sargur group of rocks. Where is Sargur group? Where does this Sargur group belong?
Dharwad.
Dharwad. Okay, it belongs to Dharwad. Okay, the basement of Dharwad. Okay, the basement of Dharwad, not basement, but the first formation of Dharwad. Okay, the first unit from the Dharwad. Sargur. From Sargur we start the Dharwad stratigraphy. Okay, then this Sargur shows concordant contact with the associated gneisses. Okay, whatever the associated gneisses are, they have the contacts with the Sargurs. Okay, now it is characterized by zircon of igneous morphology and low potassic content. Okay, so these granites which are present here, okay, the granites which are present here, they have zircons. Okay, or the gneisses which are present, they have zircons which have igneous origin. Okay, they have the igneous origin, and their content, their potassic content or potassium content is lower. Okay. There are three major phases. Okay, there are three major phases of emplacement of peninsular gneisses. They are recognized. Okay, three major phases are recognized. Okay. Now, in the western block of the Dharwad Craton, the basement cover relationship between the peninsular gneisses and the rocks of Dharwad supracrystals is more or less clear. So it is vague, basically. Okay, it is vague, so somewhat clear. Okay. Schist belt of eastern block show ambiguous, controversial relationship with the basement gneisses. Okay, so in the eastern block, as we know that there is EDC and WDC. Okay, EDC and WDC, Eastern Dharwad Craton and Western Dharwad Craton. So in the Western Dharwad Craton, okay, in the Western Dharwad Craton, the boundary, okay, the boundary and or the basement and cover relationship is clear. We know what this relationship is. Okay, what this relationship is, how this relationship is going on. Okay, we know this, or basically if it is not that even clear, but we know that what kind of relationship it might have. Okay, but in the case of Eastern Dharwad Craton, in the case of Eastern Block, these relationships are controversial. Okay, these relationships are controversial. We don't know. Okay, we don't know, or we are not able to decipher which kind of relationship is present. Okay, which kind of relationship is present. Okay, so the best with the basement gneisses, these are the gneisses, the Sandur, polar and Hatti schist belt. So it is with these Sandur schist belt, polar schist belt, and Hatti schist belts. Okay, so there are number of granitic bodies are present. Okay, there are number of granitic bodies are present belonging to third phase of evolution of peninsular gneiss complex from topographical landmarks in the craton. Okay, so granites form the this topographical landmarks. So we know that what kind of which area we are studying in. Okay. Now, one such body is closed pit granite. Okay, closed pit granite. Okay, is a larger batholith. Now, closed pit has now been renamed as Ramanagaram. Okay, closed pit is a town. Closed pit is a town in Karnataka. It is now been renamed as Ramanagaram. Okay, so but in the geological literature we still use the term closed pit. Okay. So this closed pit granite is prominent batholith. Okay, it is a prominent batholith. Okay, the batholithic body, which is in the north southerly direction for about 500 kilometers. Okay, for about 500 kilometers in the eastern parts of the Karnataka crater, that is Dharwad crater. Okay. Karnataka craton or Dharwad craton. This used to be called earlier. It used to be called Karnataka craton. Okay. So it has porphyritic granites. Okay, it has porphyritic granites with gray and pink varieties. Okay. So a major fault zone has been recognized along the eastern margin of closed pit granite belt. The granitic area dividing the craton into western and eastern block, okay, is considered to be a low pressure zone. So essentially, closed pit granite, okay, essentially closed pit granite is considered to be the boundary of distinction between EDC and WDC. Okay, EDC and WDC. So the earlier it used to be it was watertight that this is the only boundary, but nowadays Chitradurga shear zone is also being used. Okay, the Chitradurga shear zone is also being used as the boundary between EDC and WDC. Okay, so EDC and WDC boundary, there are now two boundaries. So they are actually nearer to each other. Okay, they are nearer to each other, but these again, this advancement is there. Okay. So this is about peninsular gneisses. Okay, this is about the peninsular gneisses, which is the general basement for all the formations in India, in peninsular India to be precise. Okay, it is a general basement for all the formations in peninsular India. Okay, next comes the next unit, which is called as Amgaon gneiss. Okay, Amgaon gneiss. So from here we are actually starting the stratigraphy of Maharashtra to be precise. Okay, stratigraphy of Maharashtra in Maharashtra. In the peninsular gneiss, it is general. Okay, it is general, and generally it is observable in Karnataka. Okay. Now the Amgaon gneiss. Amgaon gneiss is a granitic or gneisses that wholly surround the 3500 million year old Markampara gneiss and 3100 million years old Sukuma gneiss. Okay, this can be a potential question for you. Okay, this can be a potential question for you. Amgaon gneiss surround what? Or Markampara gneiss is surrounded by. Okay, Markampara gneiss is surrounded by. Sukuma gneiss is surrounded by. Okay, Sukuma gneiss is surrounded by age of Markampara gneiss, age of Sukuma gneiss, right? Age of Markampara gneiss, age of Sukuma gneiss. 4 questions I have told you here itself. Okay, or this can be one question. Okay, this can be one question. What is the age of Amgaon gneiss? Proterozoic, right? So this can be the potential questions from this one line. Okay. So it is granitic gneiss that wholly surrounds the 3500 million years. Remember this old Markampara gneiss. Okay, Markampara gneiss and 3100 million years old Sukuma gneiss. Okay, Sukuma gneiss, which represents widespread magmatism heralding in the beginning of the Proterozoic era. Okay, in the beginning of the Proterozoic era. Okay, so on the basis of zircon geochronology, okay, on the basis of zircon geochronology, we have devised the age for the Amgaon gneiss. Okay, age for the Amgaon gneiss is to be 2480 million years, plus minus 3. That is advisable. Okay, that is permissible. Plus minus 3. Okay, so 2480 million years. Okay, the age of the numeric age of Amgaon gneiss is 2480 million years. Okay, so by the zircon geochronology, by zircon method. Okay, because zircon is generally used as the most reliable type of material for dating. Okay, the most reliable type of material for dating of any kind of rock. Okay. The nicest as Kavadgaon gave an age of 2497 million years. Okay, again the similar nicest there. Okay. It is obvious that Amgaon gneiss belongs to the time span of 2600 to 2500 million years. So this is contemporary of the close-pit granite of the Dharwad Craton. That means when the Dharwad in Dharwad Craton, the close-pit granite was emplacing, or the Dharwad Craton was being intruded, in Amgaon there was gneisses which were intruded. Okay, this was intruded. So study like this, that in Dharwad, okay, in Dharwad, the close-pit granite is getting intruded. The close-pit granite is getting emplaced on the present place. At the same time, the same process is being done in Amgaon itself. Okay, so the Amgaon gneisses, they belong to 2600 to 2500 million years, and it becomes the contemporary. Okay, contemporary matlab samakalin. Okay, samakalin. Okay, which were emplaced at one time. Okay, at one time. Okay, so they become the contemporaries of each other. Okay, they become the contemporaries of each other. Okay, so Amgaon gneiss and close-pit granites, they are contemporaries. Next, this is what I was talking about, the Bhandara triangle. Okay, the Bhandara triangle. Okay. Now, there was one question in this paper, this GSDA paper, which is available with us. Okay, Bhandara triangle consists of. Okay, Bhandara triangle consists of 3 names they have given. Okay, so resting on the Archean basement made up of Amgaon gneiss. So Amgaon gneiss becomes the basement for this Bhandara triangle. Okay, Bhandara triangle, or whatever the rocks or whatever the groups, supergroup is going to be the part of this Bhandara triangle. The Amgaon gneiss is going to be the common basement for all this thing. Okay, the Paleoproterozoic Saucer group, Sakoli group, and Dongargarh belt or Dongargarh supergroup. Okay, Saucer, Sakoli, Dongargarh, SSD. Okay, Bhandara Craton or Bhandara triangle. BT simply. Okay, BT SSD. Okay, you can make your own mnemonics. Okay, you can make your own. Okay. BT, Bhandara triangle, SSD, Saucer, Sakoli, Dongargarh. That's it. Okay, Saucer, Sakoli, Dongargarh. Don't get confused with Dharwad. Okay. Now, so it forms the triangle of sorts in the Bastar Craton. Okay, in the Bastar Craton, they belong basically to the Bastar Craton, embracing Nagpur, Bhandara, and Durg districts of central India. Okay, the Nagpur, Bhandara, and Durg districts in central India. Okay, so in all these 3 districts in central India, we have this Bhandara triangle. Okay, we have this Bhandara triangle. Okay, the first is Saucer synclinorium. Okay, this Saucer synclinorium extend east to west in the northern part of the craton. Okay, in the northern part of the craton. Sakoli is a northeast southwest trending synclinorium in the northeastern Maharashtra. Okay, so it goes towards northeast. Okay, northeast, and 150 km long, 90 km wide Dongargarh mobile belt. Okay, Dongargarh mobile belt flanks the Sakoli in central Chhattisgarh. Okay, flanks the Sakoli in the central Chhattisgarh. Okay, so these early structures of Dongargarh belts are oriented ENEWSW. Okay, east northeast, W west southwest. Okay, so this is the overall structure of this Bhandara triangle. What you have to know, okay, what you have to know or what you have to remember from this is its components. Okay, is its components of the Bhandara triangle. Which three formations or which three litho units or which three groups constitute Bhandara triangle? Okay, constitute the Bhandara triangle. They are Saucer, Sakoli, Dongargarh. Okay, Saucer, Sakoli, Dongargarh. ठीक है? Now, the Saucer group. Saucer group. This Saucer group is a 215 km long and 35 km wide Saucer belt. It is east to west oriented arcuate synclinorium. Okay, it is a synclinorium. Synclinorium means a large fold like this. Okay, so this is synclinorium. Okay, this is the synclinorium. Okay, and the Saucer belt or the Saucer group is basically a synclinorium. Okay, let me show you the map. It will be clearer to see. This is the entire Saucer group. Okay, this is the entire Saucer group. Okay, so here like this. So it is arcuate synclinorium. Okay, it is the arcuate synclinorium. Right. Now, it comprises the succession of thrust sheets. Okay, thrust sheets including what WD West described as Devlapar Nape. Okay, Devlapar Nape. Again, this was the question in the GSDA last paper. Okay, last paper. Devlapar shows. Okay, Devlapar shows which kind of structure: fold, fault, nape, or unconformity. Okay, such were the options. Okay, I remember the question. Now, here the three phases of deformation are recognizable. Okay, three phases of deformation are recognizable in the Saucer group. Okay, so here east, northeast, west, north, southwest, trending earlier folds. Okay, so earlier they were east, northeast, west, southwest trending folds. Now they are characterized by axial planar schistosity. Now they were coaxially folded into close to tight fold. That means there were the folds like this. Okay, there were the folds like this. Now they were coaxially folded. Coaxially folded means folded along their own axis. Okay, folded along their own axis. So they become, when they were open folds, they become closed folds or the tight folds. Okay, so the resultant becomes like this. Okay, the resultant become like this. Okay, and a third generation deformation is represented by interference pattern discernible locally. So there are different these interference patterns, okay, which are shown locally at places. It is not completely seen in the complete saucer sequence, okay, in a complete saucer sequence, but it is available, or it is visible into patches. Okay, it is visible into the patches. So there are interference patterns. Okay, there are interference patterns, and these interference patterns will be seen in the local extent. Okay, so this is the map. This is developer nappe. Okay, this developer nappe is present. Okay. Now, this central part of saucer, the central part of the saucer basin, central part of the saucer basin is characterized by southeast leaning, okay, southeast leaning recumbent fold. Okay, the southeast leaning recumbent fold, and the northern flank is marked by southward thrust isoclines and recumbent folds. So here there is a recumbent fold, there is more availability or more abundance of this recumbent folds. Okay, in the eastern part of the domain, the fold plunges eastwards. Okay, the fold plunges eastwards, and in the western part, the plunge is southeastwards. Okay, these are nothing but the details of the folds and the pattern which is present in the saucer group. Okay, now they are faulted against the Tirodi gneiss. Okay, the entire saucer is faulted against the Tirodi gneiss, and the saucer group consists of regionally metamorphosed sandstone shells and carbonate rocks. Okay, now what is this Tirodi gneiss? Tirodi gneiss, okay, this Tirodi gneiss is 1525 million years. Okay, 1525 million years gneiss. Okay, 1525 million years gneissic body that appears to be product of granitization of basalt Sakoli rocks. Okay, the Sakoli rocks are present there. The Sakoli rocks might have undergone the granitization. Okay, it might have undergone the granitization, and this granitization during regional metamorphism. Okay, during the regional metamorphism, it might have created, or it has created the Tirodi gneisses. Okay, they have created the Tirodi gneisses. So from Tirodi gneisses, there might be a question. Okay, there might be a question of age and the process. Okay, age and the process, right? So age is 1525 plus minus 70, whatever. Okay, and the process of granitization of Sakoli rocks. Okay, the granitization of Sakoli rocks. This is the stratigraphic table. Okay, this is the stratigraphic table of saucer group. Okay, for the saucer group, we are studying this stratigraphic table since the BSc ages. Okay, right from BSc, when the first encounter of stratigraphy was done. From that, we have learned this table, and I hope everybody here sitting here must have learned this table by heart and must be knowing this table by heart. Okay, even which are even many of the people know the formations which are not even the part of this new succession at all. Okay, so kindly go through the succession. Okay, kindly go through this succession. Now, why saucer group is so important? Okay, why saucer group is so important? Because everything and anything, right? Why everything? Why anything becomes so important? Why anything becomes so important for us, for anybody else? Just because we have some profit, right? We have some profit. We have something to earn from it. We have something to get from that thing. Okay, and that's because we are so much interested in studying this, because the very purpose of the study, okay, the very purpose of this of study is nothing but to earn money, right? The very purpose of the study is to earn money. Why these organizations run? Geological Survey of India, DGM, that is Directorate of Geology and Mining, they come under the Ministry of Mines, right? They come under Ministry of Mines. So what Ministry of Mines needs? The minerals to be mined, right? Minerals to be mined. And the Saucer group, okay, the Saucer group is excellent in having manganese. Okay, the Saucer group has excellent world famous manganese deposits. Okay, it has world famous manganese deposits. So it has large stratiform deposits of manganese. Okay, manganese oxide. Okay, with the reserve amounting to be more than 100 million tons, 100 million tons, even more than 100 million tons. We have the manganese oxide in the Saucer group itself. Okay, in the Saucer group itself. Okay, so in the Mn oxide ore bodies, with or without Mn silicate oxide, okay, the rock which is called as gundite, okay, the rock which is called as gundite, the rock is nothing but manganese silicate oxide. Okay, manganese silicate oxide, that is gundite. Okay, the name gundite came from the Gund tribe, which is aboriginal tribe in Maharashtra, or specifically in Vidarbha. Okay, so these occur in three stratigraphic horizons. Okay, occur in three stratigraphic horizons, but the most important formation, or the most important uh, formation that contains the major deposits, is the Mansar. Okay, it is the Mansar formation. Okay, the most important and largest type of deposits. Okay, the largest deposits are recovered from the Mansar formations. Okay. Now these deposits were formed as a result of metamorphism. They are the metamorphosed deposits, right? They are metamorphosed deposits at a temperature as high as 700 and pressure 6 kilowatts. This is nothing but the information about this manganese ore. Okay, there is also uranium mineralization. Okay, there is also uranium mineralization, which is manifested in dominant epigenetic veins of uraninite. So uraninite mineral is nowadays being found here in the south side. Okay, what is, so this is all about Saucer. This is all about the Saucer group. What is, if you have any questions, do let me know till Saucer. If no, we'll move forward. Move forward towards Sakoli. Okay. So let us move forward towards Sakoli group. Okay. Towards the Sakoli group. Now, this Sakoli group is present in the northern tip. The northern tip of the Sakoli basin forms a large northeast plunging isoclinal synclinorium. Again, synclinorium is there. Okay. Again, the synclinorium is there. So early phases of deformation generated subvertical isoclinal folds. Okay, the subvertical isoclinal fold. Isoclinal means folds like this. Folds like this, which are inclined in similar direction. Okay, which are inclined in a similar direction. So isoclinal. Okay, so they are subvertical isoclinal folds. Okay, now it is exposed in eastern Maharashtra. Okay, eastern Maharashtra, Bhandara, Gadchiroli district, and some parts of western Chhattisgarh. Okay, some part of western Chhattisgarh. Now revisit that map of Maharashtra, which I have shown you. Okay, there in that map towards Chhattisgarh, okay, towards Chhattisgarh area, you have this Sakoli group. Okay, it is a 6,000 meter Sakoli succession, consists of predominantly of metapelitic rocks. Okay, metapelitic rocks with banded iron quartzite, arkose and conglomerate. Okay, arkose and conglomerate resting on the basement of the Archean Amgaon gneiss. Okay, Archean Amgaon gneiss. See, I've told you for Bhandara triangle there is a common basement. Okay, for Bhandara triangle there is a common basement, and that common basement is Amgaon gneiss. So entire triangle will be based on the Amgaon gneisses. Okay, so Sausar, Sakoli, even Dongargarh. Okay, Sausar, Sakoli, and Dongargarh. All these three will rest on the Amgaon gneiss itself. Okay, this is how your Sakoli group looks like. Okay, this is how a Sakoli group looks like. This is basically the geological map of Sakoli. Now, the lower Sakoli, okay, the lower Sakoli is essentially a volcano-sedimentary sequence which is dominated by pellets. Okay, it is dominated by pellets with rhyolite, felsic tuff, and basalts. So that is, these are rhyolite, felsic tuff, and basalts. These are basically smaller components. Okay, these are basically the smaller components, but pellets is a dominant component here. Okay, it is a dominant component here. Now, these succession, okay, the succession, it includes gritty quartzite, then phyllites, conglomerates with banded ferruginous quartzite, one set, then garnet amphibolite with chert lenses and basic tuffs of metamorphosed tuffilite, basic tuffs which are metamorphosed tuffilites. This is second set. Then mica schist, which is characterized by garnet, andalusite, and chloritoid. Okay, the third set of rocks. Okay, and metamorphosed felsic tuffs and agglomerates, which are penetrated by dikes of acidic and basic rocks. Is a fourth set of rocks. Okay, so these are the different set of rocks which are present in the Sakoli series. Okay, in the Sakoli group. This is basically the succession of Sakoli. Okay, starting with Amgaon gneiss. Okay, starting with Amgaon gneiss, then Gaikuri, Dhabetekri, Bhivapur, Pavni. This is the succession. Okay, this is the succession. Okay, and these are the rocks which are present in this succession. Okay, so learn this table. Okay, learn this table. At least you must be able to answer that match the pair type of questions. Okay, match the pair type of questions. We must know which formation belongs to which group or which supergroup. Okay, nowadays these questions are now quite common. Okay, the match the pair type of questions are now quite common. Okay, so be aware of this, because one mistake can cost 2.5 marks. Okay. One mistake can cost 2.5 marks, and 2.5 marks in MPSC means your ranks. Okay, your ranks will be here and there. Okay, so in the southern part of Sakoli basin, okay, in the southern part of Sakoli basin, it occurs strata-bound sedex type deposits. Okay, sedex type deposits of copper and zinc. Sedex means sedimentary exhalatives. Okay, sedimentary exhalative deposits. Okay, the mineralization took place close to the stratigraphic contact of felsic volcanics and chlorite schists. Okay, so there is felsic volcanics and chlorite schists. Okay, then chalcopyrite occurs as fringes and disseminations. Stratiform deposits of zinc sulfide, mainly sphalerite and sphalerite, stratigraphically overlie the chalcopyrite deposits at Polari. Okay, so here there is chalcopyrite. Okay, there is chalcopyrite, then stratiform deposits of zinc sulfide as well, and chalcopyrite deposits at Polari. Okay, also the Sakoli group is known for minor scheelite mineralization. Scheelite mineralization. Scheelite is the ore of what? It is the ore of
Tungsten.
tungsten. Right. So this is Sakoli group for us. And next and the last topic for today, that is Dongargarh supergroup. Okay, the Dongargarh supergroup. Now this Dongargarh supergroup is observed in the districts of Durg, resting unconformably on the Archean gneissic complex, the Amgaon gneiss. Again, Amgaon gneiss coming into picture. Okay, again the Amgaon gneiss is coming into the picture because it is showing the Bhandara triangle. Okay, now the Dongargarh succession comprises volcano-sedimentary rocks. Okay, volcano-sedimentary rocks which are divisible into two groups. Okay, into two groups. The Nandgaon of bimodal volcanics. Okay, the Nandgaon group of bimodal volcanics. Bimodal volcanics means which has acidic as well as mafic. Okay, felsic as well as mafic. Okay, felsic lava or felsic magma as well as mafic magma all together. Okay, and the Khairagarh of arcosic and arenite quartzites, which is interbedded with basalts and agglomerate. Okay, now these two groups, the Nandgaon group and Khairagarh group, okay, Nandgaon group and Khairagarh group, they are separated by unconformity. Okay, they are separated by one unconformity. And the Dongargarh succession is deformed into north, northeast, south, southwest striking folds of an early phase of tectonic upheaval. Okay, so it is deformed into these kind of striking folds. Okay, so there might be some tectonic upheavals, tectonic upliftments, and during these tectonic upliftments, the trend of this Dongargarh succession has become like this: north, northeast to south, southwest. Okay. Now, the Dongargarh domain, this Dongargarh domain constitutes southwards into the Bastar district. Okay, into the Bastar district as a north-south trending Putri volcanic belt. Okay, the Putri volcanic belts. The two make a 250-kilometer long Putri Dongargarh mobile belt. Okay, the Kotri Dongargarh mobile belt, and this mobile belt is nothing but the third fringe of this Bhandara triangle. Okay, now the early volcanism in the Dongargarh domain is dominated by rhyolites and tuffs, which is famously known as Bijli rhyolites. Okay, the Bijli formations or Bijli rhyolites. Okay, which is later followed by the lavas of basalts and andesite, which is known as Pitepani formation. Okay, the Pitepani formation or Pitepani volcanics. Okay, so this might be a question. Pitepani volcanics belongs to Bijli formation. Bijli rhyolite belongs to. Right. The Bijli rhyolite is enriched in LRE and zircon, Zr, then TH and Cr, but it is depleted in LILE, SC, Y, Ni, and low in Sr and high in Ce content. Okay, high in Ce content. Okay, so implied derivation from partially molten source within the crust. Okay, partially molten source in the crust. So basically, incompatibles. Okay, the incompatible elements have partially removed. Okay, incompatible elements have partially been removed. If there is incompatibles, there are some incompatibles are present, some incompatibles are removed. This shows there is partial melting. Okay, there is a partial melting, or the source which was whatever the source was present was partially molten, not completely molten, or it was not completely present. If it were completely present, it would have been enriched in the incompatibles or compatibles, and it is completely molten, it would have been enriched in the incompatibles, right? The Dongargarh granites marks the timing of a tectonic event represented by unconformity between the Nandgaon and the Khairagarh. We have seen this. Okay, so this is Dongargarh granite. Okay, the Dongargarh granite, which is present in the Dongargarh. Okay, Dongargarh supergroup, which is nearer or contemporaneous with the unconformity. Now, this is the succession. Okay, this is the entire succession of the Dongargarh supergroup. Okay, the Dongargarh supergroup, starting with Bijli formation, then Pitepani, then Bortalao, then Sitakota, Karutola, and Mangi Kuta. Okay, now there is one striking feature of this Sitagota formation. Okay, striking feature of this Sitagota formation is that this Sitagota formation has comatiates. Okay, this Sitagota formation has comatiates. Okay, the comatiate bed or comatiate, the occurrence of comatiates. Okay, the comatiates are specifically identified by this spinifex texture. Okay, this is by spinifex texture. So remember this, comatiates in Maharashtra or in Dongargarh. Okay, comatiates in Dongargarh are shown at the Sitagota formation. Okay, it is shown by the Sitagota formation. Okay, so this is it. Okay, so this is it for today. We have studied about the geology of Maharashtra. We have begun with the geology of Maharashtra. I have tried to complete the Archean portion. Okay, Archean portion. Some of the portion is left from Archean or from the Precambrian. We'll cover into next class, and we'll try to finish as much as possible in the next class as well. Okay, so